Okay, PA systems, public address systems, part 1 of 2 today. All right. Here's an example of a PA system on your left and a PA system on your right. Now there are different. There are other PA systems, as we discussed in the lecture before. These are just a couple of sort of portable systems. The one on the right is more like a speech style, slash mini stage gear, and the one on the left, instead of the loudspeakers, it does have paging horns, which are mostly used for larger areas, including the outside. And the characteristic of a paging horn is that the further you stand away from it, the better it sounds. You can see some of those on, I don't know, some utility poles in some smaller towns, or those are being used for making announcements during certain events that take place outside. Those horns are mostly designed for speech. You can play music through them, but it's going to sound quite tinny. All right. But they do a very good job cutting through the noise and other obstructions that may interfere. Now, we are in the office environment here, so we are not the only session that's going on. If the background noise gets too annoying, let me know, and I will turn on some filters here. But before we do that, I'm just going to try to do it without the filters, because the sound is going to be the best that way. Anyways, since we're talking about sound, all right. Okay, so let's get this show on the road here. PA system stands for public address. All right. Description. Let's start off with some definitions. Well, it is an audio system consisting of audio source or sources, amplification equipment, and output transducers, such as a loudspeaker. Purpose. What's the purpose of that? It's to process, amplify, and distribute audio signal or signals over a large area. It could be a theater system, it could be a house of worship system, aka church. It could be a soccer game, football game. It could be a hallway in a school, or it could be a couple of speakers in the ceiling playing background music at your local hamburger shop or a pizza shop. Okay. So that all is included in something that we call the PA systems, right? Different purposes and different shapes and forms for that. These essential parts, just as a reminder from the previous lectures, we are going to distinguish the input transducers. In this case, would be either an audio source, it could be a MP3 player, CD player, or a microphone, or a musical instrument, right? Transmitter and input signal processing. This could be, as we talked before, audio mixing board, and some preamplifiers as opposed to the amplifiers. Preamplifier is getting the signal ready for the amplifier to really give it some meat and potatoes into it. Right, and then we're going to have links and with the PA systems. For the most part, we're going to deal with cables, copper cabling, transmitting either analog or digital signal for further processing. And sometimes we're going to have that the air as a link. For example, wireless microphones are going to use air or space to transmit the signal. Also, some of the modern PA systems right now, they would have the cabling system going on, of course, from the amplifier to the loudspeakers. Some of the loudspeakers have an amplifier built into them, all right? And then they get a wireless, they could have a wired or wireless signal going into them. And sometimes you're going to have a mixing board on the stage, or some sort of a mixing board on the stage, and you're going to have a controller for that mixing board or the mixing equipment that would be mounted or located at the front of the house. Okay, so front of the house is where the public is sitting. So that's considered, with the PA systems, that's considered the front of the house. Okay. So then sometimes you're going to have, hold on, let me just, okay, we're good. So some of the control signals are being also sent either through wires, but for the convenience of things, quite often the controller will send a wireless signal to the processing unit that is right on, like, I'm just going to, for the purpose of simplicity, call it the staging area. Okay, so sometimes the audio signals are being sent, sometimes the control signals are being sent, and they could be sent through the wires, or they could be sent wirelessly as well. Okay? Also, we distinguish right now the analog systems for the PA systems, mostly for, in this case, I'm talking about stage gear. It could be either a theater or something that we refer to as the good old rock and roll type of a show. All right. Okay. Now, then we're going to have receiver. Yeah, we talked about that, and the output transducers for the PA systems. For the most part, it is going to be an output transducer in the form of a loudspeaker. And loudspeaker is just another name for a sound producing device, also known as a speaker, in short. But not always. Sometimes you're going to encounter something that is called a hearing impaired system. So the audio that is going to be on the receiving end is not going to be transmitted to the loudspeakers, but the main pathway is going to be used for a wireless transmitter, and the wireless could be either radio waves, utilize radio waves, or it could utilize infrared signals. And the people who are going to be receiving on the receiving end, they will be wearing earphones or otherwise apparatuses that can either interface with their hearing aids, or in case of musicians on the stage, there is something that's called an in-ear monitor system, monitoring system. So the monitoring system is originally, it was the most basic form of that. Would be the speakers put on the front of the stage, at the front, and pointing backwards, not towards the public, but at the speaker. So whoever is performing on the stage, they could hear other instruments or their own voice with a reference to other instruments and whatnot, so they could perform properly. Now, as the technology has advanced, something that is called an in-ear monitoring system. So instead of the speakers at the front of the stage pointing at you, or if you're the performer, you will be having the earpieces that are custom made to your not inner ear, but the ear shape that is. Everybody has their own ear shape, so it's a molded system, and the purpose of that is to block everything out that is from outside, any kind of noise or sound, and you will be having a controlled signal sent to your in-ear monitors, or otherwise known headphones. And this way you will be able to hear things properly, as far as hearing other instruments or other performance, or your voice with reference to whatever else. There are something that's called two mixes involved. One would be called a front of the house mix. And the front of the house, as we talked about, that's where the public is. That's called front of the house. Okay. And then you're going to have a mix sent to that. What is a mix? A mix is the audio signal or the sum or the combination of all the audio signals coming from the stage. So it could be different instruments, could be different speakers, could be different singers, or whatever is supposed to be heard by the public, and that all the signals are being combined in a certain way. They're being processed as far as the quality of the signal, and they're being processed as far as the proportions of the volumes, and that is called a mix. The whole combination of that is called a mix. So that mix is going to be sent to the front of the house. Also, there are separate mixes. They're called monitor mixes, and the monitor mix is for the people who are standing on the stage performing, so they could hear things properly, so they could perform properly. So basically the proper way of doing this is to have two separate mixes. So when you have when you have signals or a bunch of signals, or all the signals that are being produced on the stage, they are being split in half. So half of the signal, half of every signal that goes to the processing unit that is supposed to process the front of the house mix, and exactly the same half before it's being processed goes to the processor that is going to process the monitor mix, because you need different way of balancing the signals in various ways, so the whole mix sounds properly at the front of the house. And you also need different ways of mixing or different ways of adjusting the volumes and the quality of the signals for the purpose of the monitor mix. And the monitor could be either on-stage speakers, or it could be the in-ear monitors. So that's as far as the output transducers. And also, so for quite often, you're going to have two sound engineers. One sound person is going to basically care only about the front of the house, and that usually that person sits at the front of the house halfway through the public. You're going to see the sound booth with colorful buttons and knobs and stuff, and it's a very important looking person and that is going to mix the sound levels. And somewhere backstage there is going to be another person getting all the other half of the signal, and that person is going to mix provide the mix just for the in-ear monitors. And some of the systems are more complicated than the others, right? It's a fun thing to do, but there's not just anyone can just walk off the street and do it. There is some science involved in it, and there is some learning. So you can make a whole career doing just that, doing the stage mixing, and that could be either for the contemporary performance, the rock and roll stage type of thing, or live stage, or it could be also a live stage, but it's a different live stage, a theater type of thing. There are certain differences between one and the other, right? But for the most part, there are a lot of similarities. Okay. All right, definitions, we keep going with that. I think we're just going to be able to do just one here. So, okay, now definitions. I'm just going to put a little note here, and if you can see it, I'm going to read it for you, because Zoom sometimes, Zoom processing can blur things a little bit as far as the bandwidth. All right. Definitions, a little note here. In a written installation contracts, the language may differ. There's a reason why I'm doing this. So again, in the written installation contracts, the language might differ. Always confirm the definitions for every contract. Example, the sound system used to amplify rock concerts is commonly known as the PA system, or simply PA, while technically it could be called as a reinforcement. So just a side note, or the main notes to you, because if any one of you is going to go into this type of field, whether it will be a permanent installation, permanent installations, or live temporary, live mixing or live performances, you gotta read the contracts, and sometimes you need to confirm some of those things. This PA or sound reinforcement, this is just just a one tip of the iceberg. But sometimes people call things in a different way. Don't assume that, or don't guess if someone uses certain terminology. If you are sure, yeah, okay. If you're not sure, always call and always ask, because if it comes to live performance, you can't just put things on pause. And if you have a serious performance, concert or otherwise performance, if things are being messed up during the live performance, trust me, you're going to hear about that from more than one person. Okay? As the good old saying is, if you're ever playing in a band, the band players or the bands are probably the least appreciated people of them all. And there's that good old saying, if the party was bad, it's because the band was bad. But if the party was good, it was because the kitchen was good. Right? So that's one of those things. Right? All right, so let's just take things apart a little bit here. Zoom. All right, sound reinforcement. Okay, any system which amplifies one or more sources for a live audience. Sound reinforcement. So you get a certain type of a signal. If you're talking about 10,000 people crowd or 100,000 people crowd, then if you're just talking with your normal voice, of course, not everybody's going to, well, you won't be heard in that crowd. So you need to reinforce your sound. So that's why we use that terminology, sound reinforcement. Okay? Now, public address, PA, all right? So here's that's what is included in the sound reinforcement. So public address systems, also known as PA systems, used for public announcements, background music. I just put that good old rock and roll stage, theater, church, arena, and I'm pretty sure we could come up with a bunch of other examples, but you get the idea here. Right? Now there's sound enhancements, and we're gonna kind of touch on that a little bit, and the hearing impaired. All right. So sound enhancements usually would be used in the meeting rooms or otherwise conference environment, and we'll talk about what the differences are between this and the other, public address or sound enhancement. And also then we talked about the hearing impaired. Hearing impaired. The most in my so to speak career that that I had the pleasure of also dealing with different sound reinforcement or PA business. Hearing impaired mostly was used in the church environment, church or otherwise known technically in the business we call it house of worship, because it could well, just to be inclusive with all the different types of gathering environments for the religious purposes and whatnot. So hearing impaired, it's like an audio enhancement, mostly is being used in that environment, simply because in the church environment, there are a lot of people who are of the older age. And as we get older, we humans tend to lose hearing to the point that you need some assistance with what you need to do as far as being able to hear things. And some people are more willing to admit that they have trouble hearing than others. But there are systems for that. Usually the women would have no problem, from my experience when they installing the system. So women would have no problem admitting, yeah, okay, here's this thing, that's neat, give it to me, I'm going to use it. All right. The guys would be more reluctant to admitting until they get to try it for the first time and they were sold. All right. So that's just from my kind of a 30 years experience in being in the business, among others. Okay. Now, just a tiny bit of a difference between the public address. Well, there are certain major differences. Public address, so public announcements, stage kind of a setup. You get to amplify the signal, and the amplified signal is meant to be heard as amplified. All right, and when you have a rock concert, you know that the sound is coming out of the speakers. When you have public speech or something like that, you know that the sound is coming out of the speakers. The church environment is kind of borderline because when we used to do the sound systems in the churches, we would adjust the system so the speakers and the whole system is as least noticeable as possible. Same with the theater. Okay, the properly set up as PA system in a church or a theater is that the public could have tendencies to forget that the sound system exists. So that's a properly balanced system. You will have the illusion of the sound coming from the person's mouth, all right, not through the speakers. And you notice that the system exists when somebody pulls the plug and this thing, the whole thing goes down, and then you have trouble hearing that person. So that's a properly balanced, but still we are talking about major amplification going on here. Now, when it comes to sound enhancement, and I put this meeting rooms or conference environment, this is definitely supposed to be set up that way that you will think that the sound comes from the person's mouth. And now, when you're dealing with this kind of environment, let's just see here. There's some quite often there will be time delay involved. All right, so I'm just going to lower the light just a tiny bit, and we have a little bit of a glare from the window. So bear with me with that. I'm just going to have to reinforce the blinding of the windows. All right, now when there is, let's say there's a conference system, and I'm going to just draw a line here. There you go. There's a conference system going on here. Okay. Now let's say there is the sound, the speaker, the podium. All right. They would be right here. So this would be this main sound projection from the person's mouth. All right. Now, when you have, let's say, rows in a conferencing system, rows of seats, okay, that's where the people sit, all right, then the further you get away from the speaker, if there's no any sort of enhancement, the further you get away from the speaker, the less you're going to hear, and the bigger the room, then the problem becomes more significant, okay. So the sound reinforcement is being used either with the speakers mounted in the desktops here, so miniature or small speakers, or speakers mounted overhead, and there will be lines here. Okay, there will be lines of speakers. So there will be speakers here, there will be speakers here, there will be speakers here. What happens is that when sound travels, and you can pretty much narrow it down to 1,000 feet per second. That would be the speed of sound, all right? And it is enough if you're standing 100 feet from the person that is talking, and if you have a speaker overhead right above you, when that person speaks, the sound is going to pretty much almost immediately get through the speaker, and then just a short moment after, you're going to have the sound that travels through the air mechanically, and it's going to get to that person's ear. So you're going to have some sort of like a flange effect or like an echo effect type of a thing. And so 100 feet is not enough to create some sort of like a repetition, like a reverb type of a thing. However, it is enough to be annoying, all right? And the further you get away, you will hear sounds coming from the effect would go of a greater magnitude the further you get away from the sound source. All right, so what happens is that somewhere there would be a closet or equipment room, and there would be processing equipment, and there will be delays. So this line of speakers will be connected to one circuit, the others will be connected to another branch, and the other one could be connected to the other branch, and those branches would be time aligned. So this first row would be slowed down slightly, so the mechanical way of the sound traveling will have a chance to catch up with that, and it will be slowed down enough so they both meet at the same time, okay? And then you would have a little bit more slowed down time for the travel, for the sound to travel through the wires. It will be slowed down even more, so by the time the sound gets mechanically from that, they also meet at the same time, and so on, okay? And sometimes there will be speakers right overhead projecting in a cluster configuration, so that and that should align, that and that should align. So once you have the delays aligned, then you're a happy camper, and then you lower the volume low enough so you're not really hit by the sound from the speakers or the loudspeakers. Then you have a very comfortable sound environment for the people to be in, and trust me, that could make a big difference. The comfort of participating in such meeting could have a big difference of, after 2 hours of being in a meeting, you might be less tired if the sound travels properly. All right. Okay, so that's sound enhancement, as far as sound enhancement is concerned. And the hearing impaired, we talked about that. Just a little touch up on that. The hearing impaired usually involves wireless systems. So it would be just like the battery packs or the processor packs that people would be putting in their pocket or wearing on the belt clip. Mounted with a belt clip to their clothes. This will be wireless receivers, and there will be a main wireless transmitter somewhere in the room, transmitting the radio frequency so that everybody can tune in to that particular carrier or frequency and receive the sound that is being transmitted in that particular room. Right? So that would be radio waves or sometimes infrared. The advantage of the infrared is that the sound is much cleaner. There's less radio interference, or pretty much zero radio interference, because you have infrared transmitter somewhere at the top of the room, and you will have infrared receiver, usually mounted somewhere on the top of the headset. So usually when it comes infrared receivers, you would have something like this that you would wear, okay? And then you would have the little infrared eye somewhere discreetly mounted on top of the headphones mount, okay? So the advantage of that is the sound is much, it's a crystal clear sound. However, the disadvantage of that it has to be line of sight. The receiver has to physically see the transmitter because it's an infrared light that is being so for that purpose, there could be multiple infrared transmitters mounted around the room. So no matter where you are, you're going to make a connection with one of those. All right. So the advantage of the radio wave system is that you can just put the belt pack in your pocket or the receiver in your pocket, or you can hide it in your clothes. You just have tiny little earbuds, and you can listen to that. But the disadvantage of that, comparing to the infrared, is that sometimes you get a little bit of radio hiss or things like that. Okay? All right. So these are the three main parts of the sound reinforcement. So public address, PA, sound enhancement, and hearing impaired systems. Right now, here is this for the last 2 weeks we are doing this lab. So most of us already have performed this lab, so we're just going to touch on what is actually going on here. This is a constant voltage distributed system or distributed audio system. The purpose of that system to exist is I'm sure you have already when your DC theory, when you are joining resistors or combining resistors in series or parallel, right? What happens when you add two resistors in parallel? In series. Okay, so you just connect one end to the other resistor and so on. Then you get the resistances of two resistors added. Okay. And then you measure the resistance between these 2 points, then you're going to get whatever the resistance of this resistor is, plus whatever the resistance of this resistor is, and you're going to add them, and you're going to come up with the total resistance of these two resistors. What happens is that when you put resistors in parallel, right, then things behave a little bit differently, because when you have two resistors in parallel, when you keep adding the resistance, and you have one line here and one line here, you know, just like that. So let's say you have a resistor, you have a resistor, and you have a resistor, okay, and then you have those lines connecting those, and you are connecting that right to the main line, just like that. So these R1, R2, R3 are connected in parallel, all right? Now, what happens when the total resistance of that is, what's going to happen? Well, if you just have one resistor, then, well, if you have no resistance, there are no resistors, sorry, no resistors connected to those two terminals. Let's say we disconnect that part here, okay? Between terminal, this terminal and that terminal, what is the resistance? It's the resistance of the space between those. So you still have some resistance, a very high resistance. Well, you have a lot of resistance. I'm not going to say some resistance. You have a lot of resistance. It's pretty much almost considered as infinite resistance. Now, let's say you connect one of the resistors. Then, of course, whatever the resistance of this resistor is, you're going to have the reading between these two terminals. It's going to be much less than the air, okay? Because the air is, for the most part, considered, for our purpose, infinite resistance. Now, what's going to happen when you connect another resistor in parallel to that? Well, you are providing one more pathway for the current to travel. So you're not adding the resistances of that, all right? You're going to use a different formula, all right? So the 1 over total resistance is going to equal 1 over R1 plus 1 over R2. And then once you do the math, then you flip the result, and you're going to have the total resistance. So if you notice, if you combine these two resistors together, the total resistance of these two resistors is always going to be less than the lowest resistor, because if you have whatever the resistance of that resistor, you add one more in parallel, you provide one more path for the current to flow, so it's going to be easier for this current, main current, to flow. So whatever that resistance was, let's say this one was the lowest resistor, the total resistance is going to be even lower than the lowest resistor. Okay? Now, if you keep adding that, you're just going to provide more paths for the current to flow, and that way, if you keep adding the resistors in parallel, you are going to reduce the total resistance between these 2 points. So here's that thing. Now, when you're combining speakers, usually speakers, the loudspeakers that are being used for the distributed audio speakers, or also known as ceiling speakers, common ceiling speakers, those speakers are, the impedance of that is 8 ohms. Now, I'm not talking about resistance, I'm talking about the impedance. Resistance is resistance of and it doesn't change, it's a set resistance of a resistor, it's a linear value, linear quantity. Now, if you have something like a capacitor or an inductor, you're going to talk about reactance. What's the difference between resistance and reactance is that the resistance is set in stone. It's whatever the resistor is, it is not going to change. Maybe some little bit if the device heats up or cools down, so you're going to have slight variations, but we're not talking about that. We're talking about frequencies applied, okay? So when we have different frequencies through the resistor is going to provide constant resistance. Now, when you have inductor or a capacitor, depending on the frequency that's traveling through that, then they react differently. The inductor will have different the inductor will have different resistance depending on what frequency is trying to flow through it. Okay, same thing as a capacitor. Capacitor will have different resistance depending on the frequency that is trying to travel through that capacitor. So it's called a reactive. It's reacting to whatever the frequency is applied. If the frequency changes, the resistance of the device changes. So so that's why we are calling it reactance, like a reactive resistance. So every component has some of that. So because they are made out of, every component is made out of physical things, so it's going to have some resistance, and it's going to have some capacitance, and it's going to have some inductance. And the combination of the resistance and the reactive resistance, or the reactance of whatever the device is, the combination of the resistance and the reactance, we're calling impedance. So it's sort of like a resistance for the AC purposes, okay? So that's why we're calling it impedance. So the impedance of the regular speaker is 8 ohms, but the impedances also we're adding just like the resistances, okay? Well, for the most part, all right? So the amplifier, the main output of the amplifier, it wants to see 8 ohms. And there's something that's called the maximum power transfer. If you have certain impedance on the output of whatever device, it needs to be connected to the same impedance of whatever is on the receiving end for the power to be transferred in the most complete way. That's called the maximum power transfer. You're going to study that in some other whatever subjects if you haven't already. It's called maximum power transfer. The impedance of whatever shoots has to be matched with the impedance of whatever receives. If they are mismatched, some of the power is not going to be fully transferred to the receiver. And where is it going to go? Usually it's going to go into heat. It's going to either heat up the amplifier, or it's going to dissipate as heat in maybe the other devices on the other side, right? But it's going to be so the amplifier wants to see 8 ohms. Let's say you have 20 speakers to be connected in a larger room in the ceiling. Right? Well, those 20 speakers, if you add them, so if add 8 times 20, if you connect them all in series, you're going to have a huge impedance there, right? Because you're going to add them up, 8 times 20, right? And so that amplifier is 8 ohms, and it wants to see 8 ohms on the receiving end. So technically what you could do is you can connect series and parallel combination of the speakers. So you can, some speakers you can connect in series, some speakers you can connect in parallel in a way that you reduce the impedance and then you increase the impedance and you reduce, and then you're going to have a network of those speakers connected in a certain way that is going to give you 8 ohms on a couple of wires that you can connect right to the amplifier. No problem, all right? Well, what if you need to add one more speaker, right? Now, if you're using this, if you're installing this thing, something like that commercially, you are going to have a heck of a time trying to figure out which wires to connect to what in the ceiling between things. So instead of doing that, some engineers came up with something that's called distributed audio, that you could just have one set of wires and you can tap in parallel to that one main bus. Okay, so you can have one common set of wires and you're just tapping in parallel, tapping in parallel, tapping in parallel, tapping in parallel. You get the idea. But in order to do that, transformers have to be utilized. All right. Now, when we're talking about transformers, what do transformers do? What do they transform? Transformers transform, which means they change. Okay, they transform current, they transform voltage, and they transform impedance. What do transforms transfer or let through? Is the power. Okay, so in a transformer, if you increase the current in order to keep the same power, you're going to have to decrease the voltage. If you increase voltage, you're going to have decrease the current in order to keep the same power. Right? Those transformers behave in such way that you have a low impedance here, so we like 8 ohms, that is going to be connected. So this is the main transformer coming out of the amplifier, and sometimes it's built into the PA systems amplifier, and sometimes you need to, if it's not, you can buy external audio transformer to go through that. And it could be rated for 100 watts, could be rated for 200 watts and whatnot. And here's the low side of the transformer, the low impedance, low Z, low impedance of the transformer. Here, wrong mouse. Low impedance of the transformer right here. That goes to the 8 ohm part of the amplifier. All right, then you're going to put more wounds into the high impedance side of that transformer, and it's like 1200 ohms, 2000 ohms, something like that, right? And then you are going to connect the main audio line that is going to go along the hallway, for example. Right? Now, each speaker station is going to have the step-down transformer, because this will be considered a step-up transformer. So it is stepping up the impedance. And then each speaker station is going to have a step-down transformer that the low impedance is going to be on the side where it's 8 ohms on the speaker, and the high impedance of the side of the other side is going to be connected to the high impedance of the amplifier or the transformer here. And if you now this way, you can keep connecting all the devices in parallel, so you won't have to you will not have to think about the serious parallel combination of how you're going to connect all the speakers in order to get 8 ohms at the, and what happens if you need to add more speakers? Well, you just keep adding those speakers into that line, all right? So that's why the system like that was invented. So what's going to happen? Those transformers are going to have different taps. What are taps on the transformers? There are different points in the winding. So you're going to utilize more or less winding in order to transfer more or less power into this particular speaker. And if you change the taps on the transformer on the high impedance side, it is only going to affect this speaker. It's not going to affect everything else, right? So that's the neat thing about it, right? So you could have a bunch of speakers on the same line, on the same amplifier. You can have a bunch of speakers in the hallway, and you can tap them at 1 watt, okay? 1 watt doesn't sound like it's much, but if you have a lot of the speakers, let's say you have 50 speakers tapped at 1 watt, in that hallway you have 50 watts going through that hallway, or so on, right? So usually the hallway speakers in a school environment, hallway, they would be tapped in at 1 watt. And in order to keep the audio balance properly, there will be also classroom speakers, using school, for example. And if you usually you tap them at a 1/4 watt, okay? So they would consume 1/4 of the power that would the speaker, hallway speaker would consume. Then you have a proper volume balance. So when somebody does the all call page, things are going to sound naturally correct, right? So that's the thing. So in a summary of this thing here, we're using the step-up transformers for the audio distribution system or distributed audio system. The step-up transformer connects to the amplifier side, and the step-down transformers are connected to the individual speaker stations, okay? How does it work? This is basically the same thing, just different colors, all right? So this goes to the power amplifier, low impedance, high impedance side here, step-down transformer, should we say loudspeaker or speaker, okay? Now, how the taps work here. We're just going to consider this as let's say, a signal conditioning circuit. So it will be the signal processing, whatever that is, all right? Could be an audio mixing, some sort of audio mixing board or whatever. It's sending a signal to the power amplifier, and the power amplifier has 8 ohm, for example. Sometimes it's 2 ohms, sometimes it's 4 ohms, mostly 8 ohms. Okay, so this will be the low side of the transformer, low impedance. And as I said, sometimes those transformers are built into the PA amplifiers, and sometimes the PA amplifiers come without them, but you can buy external transformer. You can connect that right to the speaker output. All right, so now here's the main line. Let's say, okay, so this low impedance part of the transformer is just connected to the speaker, and that's it. Nothing's going to change there. But and then you have common of each transformer is connected to one line, common line here. And then you have the other side of the audio bus that you can get the signal from. So this speaker is tapped at 1 watt, this speaker is tapped at 2 watts, and this paging horn is tapped at 1 watt. Okay, so of course this loudspeaker here, the middle one, is going to consume more power, is going to produce more power, right? Depending on where you position that, sometimes you have to rebalance the audio system because it doesn't sound natural one way or the other. One thing I'm going to point out to you is that you always should keep the phase the same. If you connect, because this is a transformer output, so it's it's not connected to ground either way. And you have AC signal going through them. If you reverse the polarity on this speaker, are you going to get the sound coming out of that speaker? Yes, you're going to get the sound coming out of the speaker. But, and if it's just one, then that's fine. You're not going to see any hear any difference. However, if you connect one speaker one way and you reverse the polarity on the other speaker, and then you can, if you mess up the polarities, you're going to have the sound coming out of the speakers out of phase. What does that mean? Speakers have membranes, okay? How do they produce the sound? They move the membrane back and forth, and they move it in a fast way to produce longitudinal waves that move the air, compress and decompress the air, and that's how sound happens. So if you have two speakers, those two membranes should be in sync. They should always work together. If you have one speaker, if you reverse the polarity, the connection polarity on one of the speaker, then you're going to have the opposite effect. If one pushes, the other one pulls. You're going to have something like that. Are you going to hear some sound? Yes, you're going to hear some sound, but it's going to be annoying, and you will not know why if you're not in the PA system business. And of course, some of the power might get canceled if they are close enough to each other. But for the most part, it's going to sound uncontrollably weird, annoying. It's going to make your head kind of twist one way, right? And so it's going to be annoying, and you will not know why. So that's why things should be in phase. Okay. All right, we're almost done here. Constant voltage distribution system, components of that. So the stuff that most of us, we had the chance to play with already, and we're just wrapping up this whole lab this week, is the 70 volt speaker station. They also come with 25 volts version. So 70 volt is, well, if the volume is full, then you're going, if the signal is at the full strength, you're going to have 70 volt peak to, or RMS, going through the audio line, okay, the main audio line. So that's why it's called 70 volt, or the other ones are called 25 volt systems. So depending on and the PA amplifiers, they would have, quite often they would have 8 ohm output, and they would have, some of them, they would have 25 volt output, which will be the built-in transformer inside, and sometimes they will also have 70 volt output. So if you're using 70 volt speaker stations with the transformers that are designed to handle the 70 volt system, you should connect the whole thing as a 70 volt system and plug it into the amplifier where it says common and 70 volts. If you use the 25 volt system, use the according output, okay? A designated output, all right? And then so that's the back of the amplifier here. For example, what do we have here? Okay, so this PA amplifier has the common. This is the output, the speaker output. Okay, so here's the common. So that's common point for all of those outputs. And if you have 4 ohm speakers, you connect these two. Right? If you have 8 ohm speakers or speaker, then you connect common and 8 ohms, and that's the other side is going to be connected to a speaker. Oh, this one even has 16 ohms, all right? And then look at this. This one has 70 volts. So if you use the 70 volt system, you would use one of the conductors connected to the common terminal, and the other one will be connected to the 70 volt terminal, and that's how this one will work. Okay. And over here, this is these are the inputs of that. All right. And here you have different inputs connected. So you have microphone 1, microphone 2, and here's the volume control for microphone 1. Here's volume control for microphone 2. Here's a phono or auxiliary input. It would be probably at the back somewhere. Auxiliary input. Yeah, there we go. There's some more input at the back. Here's auxiliary inputs, and here's a phono input, and there's a mix bus input. So you can use the, well, each amplifier works slightly different, so you just kind of have to figure out how this particular one works that you have. Now we also connect the volume control. All right, we are connecting a volume control in our lab. Also here we have a 70-volt paging horn. If it's a room environment, you would tend to use the speakers like that, ceiling speakers, or you can mount them in the walls as well. But if it's a large production hall with a lot of noise, or if it's outside, I would suggest using paging horn, and put those paging horns, try to cluster them in one spot, because the sound reflects off the walls before it comes to person's ear. Okay, so if you have a large production hall, the sound is going to reflect off the walls no matter what. But if the sound comes from one source, you're going to have less combinations of reflections, as if you had a paging horn in one space, paging horn somewhere else, and paging horn somewhere else in the same room. You're going to have a huge mess as far as the sound coming to your ear, reflecting off all the walls, ceiling, and floor, and whatnot. And something that's called the speech intelligibility will go down, which means you're going to get the volume, you're going to hear it's going to be loud, but because the sound reflects from multiple sources from the walls at different times, uncontrollably, you are not going to be able to hear things as clearly as you would if the sound was coming from one source. So if you need more than one paging horn in the room, try to put them close to each other and point them slightly different away from each other. So this way, you will have that same common point that the sound is coming from. All right, here's the example of the step-down transformer. What do we have here? On one side of the transformer, you're going to have the 8 ohm wires. They're going to be labeled 8 ohms. And then you're going to have one, this one's in black here, right there. And it says black, says common. And this one here, you can see 70-volt line, all right? So it's a 70-volt transformer. So we're going to have, connecting to the high impedance, the power audio bus, you're going to have a common, and then you're going to have 10 watts, 5 watts, 2.5, 1.25, and so on. And these are the color code for the wires that correspond to the wires coming out of this transformer. Again, as I keep saying, this is 5 to 1. So if you need to go, please go. This will be posted on YouTube. You can catch up with that later. Sometimes we go a couple minutes over time when it comes to I just want to finish this, at least this part of this class. All right. So yeah, I don't want to cut into the time for I think Mr. Hager, is it? Yeah, so there you go. I'll just keep talking even if you leave, and then I'll post it. You'll be able to watch this. Just just catch our YouTube playlist that is included in the class portal announcements. All right. So that's what does it mean 10 watts, 5 watts, or 1.25 watt? Just a side note: if it says 1.25 watts, that means it's a 1 watt. Generally speaking, just don't want to say 1.25. It's a 1 watt. What's a 1 watt tap? Here's a 2 watt tap or 5 watt tap. Okay, that means at the full volume, if you use the black and you use the let's say orange wire here, and you connect only those two to the main audio line that's coming out of the amplifier at the full volume, this speaker that has 8 ohms on the other side is going to produce 2.5 watts of power. Same as if you use the blue, is going to produce 5 watts. All the other ones, you just cut them off and blind them so they don't short to any other structure or each other. Okay, and the other 2 wires are going to the speaker. So that's, it looks kind of intimidating, complicated, but it's not. Right? All right, so here's another example of a transformer. Different depending on the manufacturer. The idea is the same, but some of the packaging might be different. What do we have in our classroom? We have those taps. So we don't not using the wires. We have the taps and we use the spade connectors to clip onto them. So here's common. This tap would be 20 watts and those taps are labeled. On our speaker system, we have taps that are numbered on the transformers, and on the speaker, the backside of the magnet, you have, if you use a 25 volt system or you use 75 volt system, if you want to tap into 1 watt, you are going to use tap number, I don't know, 6 or 5 on the transformer, right? How does the volume control work? Okay, now here is the line you're tapping in. If you want to interface the speaker with the volume control, this is what we did in the lab. You tap into the main audio line with the input of the volume control, and the volume control is just another transformer. That is the same thing as we do the manual taps, but it has a control knob that you can select the numbers, and instead of tapping things physically, you're going to switch the connections inside that assembly right here that is going to select different taps, and so you can use it as a volume control, right? You're tapping into the volume, into the main audio line with the input of this. So it says, for example, this one says amp plus, amp minus, okay? Just so you can keep the phase in control, right? And then the output of the volume control goes straight into the speaker station, right? So when you are adjusting this volume control, you're changing the taps on this transformer, so you're changing the amount of power that's going to be sent to this. And when you're using that, you're only controlling this speaker. Everything else is being not affected because everything is connected to transformers, and the transformers kind of work within themselves and with each other of how much power goes where, depending on the proportions and the coils and the impedances that are connected with each other. So it's also acting as an impedance matching transformer because you have a high impedance on one side and a low impedance on the other side. So the transformers transform impedances. Sometimes when you're designing a circuit, like an audio circuit, for example, if you use a 555 timer to produce a certain sound wave, and if you want to connect a little tiny speaker that is going to recognize that, produce that sound, and if you don't have enough power being transferred to that speaker, use just an insulation transformer. Right, you can, because you could have different impedance coming out of the 555 timer, and you can have a different impedance at the speaker. You connect those two, you don't get the maximum power transfer. But if you use just an isolation transformer, those impedances are going to, it's going to be called impedance matching transformer. Trust me, the sound is going to be coming a lot louder through that little tiny speaker. All right, so that's as far as that. Now, as a note here, those volume controls, they are kind of bulky because there is a transformer here. If you use the box, and which you should because it's a 70 volt system or 25 volt system, you don't want any mess to go in there. Electrical boxes, you need to use the deep electrical boxes for that, so you can put in that transformer comfortably. Some of the regular depth device boxes are not going to cut the mustard, all right, if you will, because so you guys gotta make sure if you are installing the system by yourself, or if you have different contract, if you work as a contractor and your job is to mount the system and somebody else's job is to provide the infrastructure to you or for you, then you should kind of synchronize with the other company who is installing the pipes or the conduits and the device boxes, just to make sure that wherever there is a volume control, you should have a deeper device box there, right? Here, how this is solved here. This is a typical example of the speaker station. So as we talked about, okay, so here's the low impedance terminals, and they are permanently mounted right to the 8 ohm side of the speaker. Then you're going to have, depending on how you want to tap things, you're going to get the you're going to connect either the common and whatever the color of the wire. So you're always going to have two connections: the low impedance, two wires, and the high impedance, only two wires. The other ones, cut them off, not entirely, but just cut them so they don't short. And sometimes you're going to use capping devices to cap them off. The small wire nuts work pretty much well in this case here. All right. So what do they say here? Low input terminals, low impedance, go to 8 ohm, connected to the 8 ohm loudspeaker terminals. Here's a step down transformer because we're getting the signal from the high impedance side and we're transferring the signal into the low impedance side. So it's a step down transformer. The one at the amplifier, it's a step up transformer. Okay. And then there is the high impedance terminals. Roughly around 1200 ohms, connected to the main speaker cable in a bus-like configuration. The main speaker line runs from the 70 volt out or 25 volt output of the PA amplifier. All the speaker stations connect to that line in parallel. Right? So that's the idea of the distributed audio. Right? Now, also when it comes to mounting those speakers, usually they'll be mounted in the ceiling grid. Now, if you notice, here's a ceiling grid and there will be ceiling tiles. Now, they should not be mounted just on the tile. Those tiles are made of soft materials, and if you just mount the speaker just on the tile, that thing is going to sag down and it's going to hit somebody in the head. Okay, the mounting rails, they have different forms and shapes depending on who makes them. Sometimes you have the whole mounting assembly. Then the endings of those rails are resting on the metal structure on the grid. Right? So even if you have no tile, then the speaker this whole assembly should be resting on the grid here, okay? And the tile is just going to be there for the aesthetic purposes. Same as that, you see here's the light, okay, mounted. Before even the tile is put in, that thing is just hanging on its own, mounted to the grid. It's a safety thing, all right? And also on top of the ceiling speakers, you're going to have those popularly called the cans, okay, or they call it back boxes. So the speakers are not the whole guts of the speakers, if you will. They are not exposed to everything else that's in the ceiling, and so those sometimes are being pre-assembled on the floor with the wires sticking out. And then once they put in the ceiling, then the wires hanging, and then the next step of the installation would be just connecting those wires, just as we connected those in the lab, or some of you still will do that this week, right? So that's as far as mounting those speakers. Well, if it's a nicely sized ceiling space above the ceiling tiles, sometimes the speaker would have tendencies to sound better without the back boxes, because then the whole ceiling space could be used as a resonating box. However, in a lot of cases, it's not permitted by the electrical code or the building code. So always confirm if you can do this or not. Usually, in the earlier years, some time ago, you were able to get away with mounting them with those speakers without the back boxes. Now the rules and regulations are being tighter and tighter anymore. So quite often you just won't be able to do that. So you're going to have to use the back boxes. Hey, you know. And this is the end of this presentation for today. So we just went 6 minutes over time here. All right. Okay, so next time we're going to see each other, we're going to tackle the part 2 of the, PA systems, and we're going to continue with more stuff later on. And I'll deploy the quiz sometime this week, and I'll give you a couple days, 2 or 3 days to complete that. It's going to be a simple quiz. You will see, once you get the first, all my tests are being done that way. So it's going to be quite self-explanatory. Don't worry about it, okay? The instructions will come with the quiz. All right, so that's it for today, and I'll see you when I see you. Thank you very much.